Hi, welcome to 1.2, our video on taking measurements. Our learning goals for today are to identify the estimated and measured digits inside of a measured number, to determine the level of precision of an instrument, to determine the number of significant figures in a measurement, and recording measurements on various instruments. So let's start by looking at this measurement down here, 17 centimeters. And 17.0 centimeters. These are actually two different measurements and they don't equal each other. So how are they different? Well, we can tell that 17 centimeters here is measured with a different instrument than this one is. We can tell that this one measured to the tenths place, whereas this one only measured to the ones place. So we would say that the instrument that measures to the greater decimal point versus the one that only measures to 17, we would say that this particular measurement is more precise. Now, this is not to confuse you with when we talk about whether a set of data points is precise. This is a different vocabulary term. When we're talking about instruments and measurements, we're talking about precision of a measurement. And so a measurement that goes further into the decimal point is going to be more precise than the measurement that does not. Let me show you some examples. We'll first start by looking at a ruler and a nail and practice measuring a ruler and a nail, and we'll talk about the precision of the ruler. Before I move on, I want to clarify some vocabulary terms. I'm going to use the word increment, and increments are the marked lines on I don't know why I put unmarked here. They are the marked lines between they are the marked lines on an instrument. I'm not sure what this is saying here. So the lines here that are by the numbers, these are marked lines. So this is an increment. But we also have smaller increments that are marked here, and a medium-sized increment right there. So these are all considered to be increments, okay? They're all marked lines on our instrument. Now, when we begin measuring, we always begin putting our item on the 0 line. So we take the nail and we put it all the way here to the 0. And the level of precision is going to be the smallest marking on your instrument. So I would not say, we can see that the biggest increment line right here and right here, these are measuring to what decimal place? Well, we can see that they are measuring by ones, and so these are measured to the ones place. Now there's a smaller increment right here, the one in the middle, and that is halfway in between 4 and 5, and halfway in between 3 and 4, and halfway in between 2.3. So that's measuring to the 0.5s, to the 0.5s, okay? That's what that increment is measuring to. Now there's an even smaller increment right here, and these, if you count them out, they are all the numbers in between 3.0 and 3.5. So these are going by 0.1s. So that is the level of precision of our instrument. When I'm asking for level of precision, I want to know what the smallest marking on your instrument is measuring by. Now there's two more vocabulary terms we need to define. The first is a measured digit. A measured digit comes from actual physical markings on the instrument. So if we were going to look at the measured digits for this nail, I will zoom in over here so we can see the tip of the nail. We can see that it's at the 6 mark, so we're going to write 6. That's a measured digit because it's an actual line. And then we can see the nail goes right in between this line and this line. So we are going to say, let's say this is 6.1, 0.2, 0.3. So 0.3 is actually a measured line on the instrument. So these are both measured digits, okay? Now an estimated digit is the digit that the scientist always estimates, and will always estimate one more decimal place after the measured digits. Think about it as the scientist is given the honor of being able to guess what the next increment would be. So we see that this tip of the nail is in between 6.3 and 6.4. So what number am I going to want to estimate after the 3? Well, it would make sense that I would estimate a 5 because that's halfway in between 6.3 and 6.4. So this is an estimated digit, okay? Any measurement that you look at is going to have measured digits and estimated digits. The estimated digit is always the last digit in the number, okay? So this is our 3-step process in taking any measurement. The first is we determine the level of precision of the instrument, which we did, and it was, the level of precision is the 0.1s. Then we record the measurement to the smallest marking, which we did. These are our measured digits. And then lastly, we always estimate one more digit, which we did. So let's do a couple more practice problems. Here's an example of a graduated cylinder. A graduated cylinder is a cylinder that contains liquid, and we measure the volume of the liquid. In a graduated cylinder, liquid will always form a meniscus, which is this rounded top of a liquid. And when we measure, you might be confused thinking, well, where am I measuring on this line since it's not straight? You always measure on the bottom of the meniscus. So here's our meniscus here. We're going to measure on the bottom, and you can see it's right at this line. So before we write down our measurement, we need to follow our step process. The first step is finding out what the level of precision is. So that's the smallest marking. We see the big marking here goes by tens, okay? But that's not the level of precision. We go smaller, and we can see this is the 5s, okay? 70, 75, 80, 80. And there's an even smaller marking here, and these markings go by 1s, because I can see that there's 10 of these marks between 70 and 80. And so 10 between 70 and 80 means it's going by the 1s. So our level of precision is the 1s place. The next, we're going to record all of our measured digits. So we see in a graduated cylinder, we always measure from the bottom up because we want to measure the volume of the liquid, not the volume of the air above it. So we started at 0, and now we come to the 70 line. It's definitely at the 70 line, so we're going to put 7. That's a measured digit. Okay, and then we are going to measure to the smallest instrument. So the next smallest instrument are these 1s. So 1, 2, 3, 4. It's at 74. That's another measured digit. Now we get to estimate. Now, it might look like it's exactly on the line. And so if we think it's exactly on the line, our estimated digit can be 0. That's okay. We can estimate as 0 if we think it's right at 74. Sorry, that was our third step. Our third step was estimating the next digit. Kind of got ahead of myself. Okay, the answer here is not 74, by the way. It's 74.0 because we have to estimate. Let's look at another example. Here we have our 2 measurement values that we looked at the very beginning of our lesson. 17 and 17.0. What's the difference? Well, the difference is that I can look at these numbers and I can determine what type of instrument was used to measure it, because the last digit here is always the estimated digit. So that means in this measurement, 7 was estimated, and in this measurement, 0.0 was estimated. And then all the digits before it were measured. Okay? And so I can tell that if this is the estimated digit, the one next to it is the level of precision. So this measured by tens, this one measured by 1s, because it's always the measured digit that's closest to the estimated digit. And so here is a picture of the car that was measured on a ruler by tens, and a car that was measured, the same car that was measured on a ruler by 1s. So now we're going to move on and talk about very briefly about significant figures, about counting significant figures. So a significant figure is basically just figures that are figures. You can also say significant digits. I usually say significant digits. These are numbers that are important. So you might want to write that down. They're just numbers that are important. And the reason why they're important is because they were measured or they were estimated. So any measured number and any estimated number is considered a significant digit. So you might ask, well, Miss Millsap, what is an insignificant number? And the answer is that there are some zeros that are present in numbers that were not measured and were not estimated, and those would be considered insignificant. So we're going to look at this number here. This number says 0.00400450. That is a very long number, and it's also incredibly precise. Look at the level of precision. Goes to a very small number. We always talked about how the last digit is significant. The last digit is significant. If it's a 0, we don't know if it's a significant number or not, and I'll kind of explain why. But basically, zeros at the end of the numbers are significant if a decimal is present, okay? Zeros at the end of a number are considered significant if a decimal is present. Regular numbers are always significant because they were measured. Zeros that are in between numbers are always significant, and zeros at the beginning are never, ever, ever significant. So those are our three main rules. Zeros at the end count as significant if a decimal is present. Zeros in the middle always count. Zeros at the beginning never count. Now let me walk you through what that means or what that looks like with these four problems. So here's 130.1 milliliters. So we know that the last digit is always the estimated digit, right? And so that's significant. This is the level of precision, and all of these are measured digits. This is the level of precision because it comes right before the estimated digit. So that's why zeros in the middle always count as significant. So this has 4 significant figures. This next problem here has no zeros, so we know they're both considered significant, 2 sig figs. If I asked you to label them, this would be your estimated digit, this would be your level of precision, and your measured digit. Now let's look at this one. This is 130. What is the difference between 130 milliliters and 130 point milliliters? Well, the difference is it's trying to explain whether the zero was estimated or not. And so if the zero was estimated, if we're going to count it as a significant figure, then we put a decimal there. Remember the rule that if there's zeros at the end, they only count if there's a decimal present? The decimal marks the zero as being significant. And then the level of precision here is the tens place, whereas this one has no decimal. So that means the zero is not significant. It means it's a placeholder. It's not actually the estimated digit. The estimated digit was in fact 3, and then your level of precision is the hundreds. Okay, that's a measured number. So whenever you're measuring, if you were measuring by hundreds, this would be what your number would look like. If you were measuring by tens, this is what your number would look like. Okay. If you were measuring by ones, your number would look like this, because this would be your estimated. This would be your measured number, measuring by ones. And then these are also obviously measured numbers. So this would have 4 significant figures because these zeros are at the end and they count because there's a decimal. This zero is at the end, it counts because it's at the decimal. So this has 3 significant figures. And this zero does not count because there's not a decimal present. So it only has 2 significant figures. Okay. And then this last one we just did, it has 4 significant figures. The zeros at the end count because there's a decimal present. It doesn't matter where the decimal is, as long as there's a decimal somewhere, they count. Now, the only thing I didn't show you are leading zeros. Let's say you have a number like this. This zero does not count. It was not measured. It's just a placeholder. Same with this number here. These zeros don't count. They are just placeholders for the 6. The 6 was actually measured, okay? If I had 6 with a 0, this 0 is also considered to be significant because it's at the end and there's a decimal present, okay? Let's see. This one here would be considered insignificant because they're at the end and there's no decimal present. So these two are the significant numbers. And that is it for this video.